In this video, we're going to talk about the discriminant of a quadratic equation and also look at some key features like the axis of symmetry, the roots, and the turning point values or the vertex. So we're going to start with maximum and minimum. Okay, a minimum in a quadratic occurs when a, remember a is the coefficient of the squared variable, is greater than 0. So if a is greater than 0, the quadratic opens up like that, and the vertex occurs down here, which is a minimum. And you can justify it's a minimum by saying a is greater than 0, thus minimum, if that's something that you're asked to do in the equation. A maximum, the opposite happens. So when a is less than 0, our parabola opens upside down. So the vertex occurs here, thus it is a maximum. And that we call it that because if we start here on our x-axis and we start moving this way, we're going to start moving up. We're going to start moving up on the y-axis until we get to this point, and then we're no longer going to increase in the y, and then we're going to start going back down. So this on the y-axis is our maximum. So that's where the term maximum and minimum come from. The vertex, you get from vertex form. Generally in the United States, vertex is referred to as h comma k. And your axis of symmetry, so if your vertex is down here, your axis of symmetry is always going to be x equals, and then the x coordinate of your vertex, which we usually denote as h. So it's x equals h. So you've got your vertex, whether it's a maximum or minimum. We can figure out the coordinates of the vertex, and now we can name the axis of symmetry of a parabola. So let's try this first one. So it says express negative x squared plus 5x plus 7 in vertex form. So you put it in vertex form. So a is -1. You're going to get a equal to +1. So you've got to factor out the -1. And we get that negative x minus 5 pounds squared plus 53 over 4. And we want it in this form, so I have to move this up front. So it's 53 over 4 minus x minus 5 over 2, and all of that is squared. So now it says find the coordinates of the turning point of that function and state whether it is a maximum or a minimum. Well, the coefficient here tells us that a is less than 0. So therefore, we open down as a maximum, and we can state the maximum occurs at 5 halves. Inside the parentheses is always opposite what you think. The outside is as is. So your vertex is 5 halves comma 53 fourths. and that is a maximum. So there's one for you to try on your own. Next thing we look at when we're talking about quadratics is we often talk about the discriminant. The discriminant is the part that is under the radical in the quadratic formula. So it is just the b squared minus 4ac. That is the discriminant. The discriminant is called that because it discriminates answers. If your discriminant is less than 0, so if it's up here on this yellow curve, if it is less than 0, you have complex solutions. So meaning you have I involved. Be careful. It doesn't mean there are no solutions. What it means is there are no real solutions. If your discriminant is equal to 0, that's our red curve here, that means that it's a double root. We only have one real solution. And then if b squared minus 4ac, if the discriminant is greater than 0, it's our blue function here, you have two real and unique solutions. So if you see a problem that's talking about the nature of the roots, it's talking about the discriminant. And if you hear something talking about one real solution or unique real solution or no real solutions, you know they're talking about the discriminant. So let's see what this looks like on an example. So this particular problem, we have kx squared plus px plus 5 has repeated real roots. So if we go back and look at our notes, repeated real roots is this one right here. So we're going to say that the discriminant, so b squared minus 4ac, needs to be equal to 0. At this point, we just need to identify what a, b, and c are. So a is always the coefficient of the x squared term. So in our case, it is k. B is always the coefficient of the x term. So in our case, it's p. C then is always whatever is not with x, and it's 5. This is true no matter whether you have 5 plus f or whatever is left over, that is all your c term. Let's plug these in and see what we can have happen. So we have p squared minus 4 times k times 5 all equal to 0. So you end up with p squared minus 20k equal to 0. Now, it says find k in terms of p. So what they're asking us to find is k equals some equation with the variable p in it. That's what that question means. So I need k by itself on one side and everything else on the other. So we're going to move that over there. So I'm going to end up with p squared equals 20k. And then I'm going to get k equal to p squared over 20. So that is the variable k in terms of p. When we get to quadratic inequalities, which we get to using the discriminant, the process is the same, but remember when working with inequalities, if you multiply or divide by a negative number, you flip the inequality symbol. So if I have negative x, for example, if I have negative x greater than 2, and I want my x to be positive, I'm going to divide by negative 1. So I'm going to have x is now positive, 2 is now negative, but instead of my inequality symbol being this way, I have to flip it, and it is now this way. So that's what it means. So let's work this one out. So 2x squared plus 3x minus 27 0. So we get x is 3 and x as negative 9/2. Now, the other aspect of inequalities with quadratics is that there is no way to know definitively how the inequality symbol should go from the math. Easiest way is to guess and check. We have these two solutions, 3 and negative 9/2. So if we look at this on a number line, with 0 being in the middle, this being 3, this being negative 9/2. We ask ourselves, what is a nice, convenient number to do math with that falls in between those two numbers? Well, 0 happens to fall in between those two numbers. You could use 1. You could use any number you want to as long as it falls in between those two numbers. So I'm going to choose 0. So I'm going to plug in 0. Into the original equation. I'm going to evaluate. So I get negative 27 less than 0. That is true. So what that tells us is that our solutions are in between the two values of x that we got. Quadratic inequalities are either going to be inclusive meaning like this one, or exclusive, meaning they go the other way. So for this, we would say x is between negative 9/2 and 3. So in this video, we looked at the discriminant, what it is, how to use it, and we also looked at the key features of a quadratic, namely the axis of symmetry, the vertex, and naming the vertex in terms of is it a maximum or minimum, and how can you tell?